Hello, my name is Professor Martin Warren, and I'm Professor of Biochemistry in the School of Biosciences at the University of Kent. And I'm going to be talking to you today about one of my research interests, which relates to some of the royal diseases, and in particular concerning King George III's madness. What do we know about King George III? Well, King George III is best known as England's mad monarch. He's actually one of the longest serving monarchs behind Queen Elizabeth II and Queen Victoria. And he was on the throne for around 60 years, from 1760 to 1820, although for the last 10 years he suffered with dementia. But certainly for the first 50 years of his throne, although he is known as England's mad king, he maybe was mentally unstable for a total of about 6 months. The most famous period of his mental illness was the so-called Regency crisis, which forms the basis of Alan Bennett's very famous play and film, The Madness of King George. And during that Regency crisis, the king completely lost his mind, and there was an attempt to replace the king with the Prince Regent, the future King George IV. So what was wrong with King George III? What was it that caused his madness? And these were questions that have been addressed by a number of people retrospectively after the king had died. And the first of those attempts to understand why the king went mad was done by an American psychiatrist, Isaac Ray, in 1865. And he suggested that the king suffered with mania. That diagnosis was then followed up in 1945 by another American psychiatrist, Manfred Guttmacher, who suggested the king was suffering with manic depressive psychosis, where the king was unable to cope with serious events that were happening in the kingdom or in his personal life, and those brought on the bouts of madness. That led to an interpretation of what the king was like. So historians looked at him as being somebody who was comparatively mentally weak, couldn't cope with pressure, and when things went wrong, he suffered with his madness. This whole idea was challenged in the mid-1960s by a German-born mother and son team, Ida McAlpine and Richard Hunter, who were both psychiatrists themselves with a strong interest in the history of psychiatry and in the interest of famous mad people. And this brought the king to their attention. And what they noticed that when they were studying the king's bouts of madness was that every time the king went mad, he suffered with a number of physical symptoms. And this suggested to them that the king was suffering with an organic illness, a metabolic condition, one of which symptoms was madness. And they recognized that as being a condition called porphyria. So how does porphyria relate to heme synthesis? Well, heme, as an essential life pigment, is made in quite large quantities within our bodies. And it's made from a small molecule, which is pieced together through the action of a number of enzymes, 7 enzymes in total. So there are 7 steps that take a small molecule, piece it together to give a much larger heme molecule. And for every one of those enzymes, there's a gene associated with that enzyme. It encodes the enzyme. And occasionally, molecular defects creep into those genes. And those molecular defects means that those enzymes, for people who have those mutations, will suffer with a metabolic problem. They won't be able to make heme in quite the same way. And what happens is that with those mutations, is that you get a blockage in the pathway. And as I said, for every one of those 7 steps, there is a known genetic mutation. So there are at least 7 different types of porphyria associated with the biosynthesis of heme. And the king is thought to have suffered with a defect in this step here, number 6 in the pathway. And a defect in that step gives rise to something called variegate porphyria. Now, with heme synthesis, it's in effect a deficiency of the heme biosynthetic enzyme. It's not that the person can't make enough heme. If they didn't make enough heme, they would die. They still make heme, but what you get is a blockage in the pathway. It's a bit like a crash on a motorway. You can still get traffic going past, but you get a tailback. And it's that tailback which causes the problem, because you get a buildup of those intermediates in the pathway. And those intermediates have a toxicity. And the toxicity of those cause the symptoms that are associated with porphyria. So what are those symptoms? Well, the major clinical symptoms of porphyria include severe abdominal pain, muscle weakness, and a psychiatric disturbance. And that's because some of those intermediates in the heme pathway interfere with our neural system. So they interfere especially with our autonomic nervous system. Patients can also suffer with skin lesions. If they are exposed to bright sunlight, their skin can blister. So they're very photosensitive. They can't go out in bright light. And that again is because some of those intermediates actually react with sunlight in a very unfortunate way. But in both sets of conditions, those intermediates in the pathway get excreted, and they get excreted largely in the urine. So that the urine of patients who suffer with porphyria can appear quite red or black, depending on which intermediates are being excreted. Ida McAlpine's and Richard Hunter's idea of the madness of King George III being associated with porphyria was met with a certain level of skepticism. And although they provided quite good historical evidence, they were never able to take it to the next step of using modern molecular genetic approaches to investigate the condition. And one of the things that we thought was to try and see if we could apply those kinds of approaches to see if we could find the absolute genetic evidence that the king suffered with the condition. The king is actually buried in St. George's Chapel in Windsor. And although we sought permission to exhume a small part of the king to investigate, we were politely told that that wouldn't be possible. But McAlpine and Hunter had shown that since this is a hereditary condition, that there seemed to be evidence from Mary, Queen of Scots, down to really some quite recent members of the royal family who suffered with porphyria. And through a collaboration with Professor John Roll at the University of Sussex, we were able to identify symptoms in some of Queen Victoria's descendants. And in particular, through the line that went through Queen Victoria's eldest daughter, Vicky, through her eldest child, Charlotte, and through her only daughter, Theodora. And Theodora and Charlotte in particular sent letters between themselves and to their grandmother, explaining some of the symptoms that they were suffering, which included the production of this discoloured urine, all of which is highly consistent with them suffering periodic bouts of porphyria. With John Roll's help, we were then able to get permission from the appropriate authorities in both Germany and Poland to exhume both Theodora and Charlotte. And from the material that we obtained, which were some small bone samples, we were then able to extract their genomic DNA and do an analysis to see if we could find any mutations in the relevant gene that's associated with variegate porphyria. And although we found a mutation in that gene, that mutation itself is not absolutely cast iron proof. But at the same time, we were also able to find some more historical evidence that the condition had been passed into the more recent generation of the royal family. And in particular, we found evidence that Queen Elizabeth II's cousin, Prince William of Gloucester, was diagnosed by 3 separate physicians, each of which concluded that the prince was suffering with variegate porphyria. All of this is consistent with the fact that the king is likely to have suffered with the condition and to have passed it down to future generations. So as far as I'm concerned, the mystery isn't so much as to whether the king suffered with variegate porphyria, but as to why the king actually had that condition comparatively late in life. During the Regency crisis, he was closer to 50 years of age, and yet the attack was actually quite prolonged. It lasted several months. And we wanted to know what was it that made those attacks so severe? And could it have been affected by the medication that was being given to the king? And to help address that question, we were contacted by the Science Museum in London, who had part of the king's hair, or a hair locket of the king, on display. And they gave us a couple of strands of hair. And although we looked at trying to extract genomic DNA from the hair, that wasn't possible. So we looked to see if there was anything else in the hair that could have been evidence that the king might have been affected by outside influences that could have affected his condition. And particularly, we were thinking whether heavy metals such as mercury or lead could have had an effect on his illness. And when we analysed the king's hair for both mercury and lead, we did find some elevated levels present. But what really took us by surprise was the fact that the king's hair had a huge amount of arsenic present in it, much higher than in our control samples. And so we wanted to determine whether that arsenic was really embedded within the hair or whether that arsenic had been added externally as part of the preservation process of the museum piece. So we did quite a complex analysis on that hair sample. We did a particular analysis that involves a type of mass spectrometry, which allows us to look at the metal ion composition within the hair and to see whether it is embedded within the hair along the fibre or whether it has been applied externally. And what we found was that on the whole, in comparison to all our control samples on this logarithmic scale, we found that the king's hair sample had between 100 and 1,000 times more arsenic in it. But because of the consistency of the level of arsenic in it, the arsenic must have been laid down inside the hair and not externally added to it. So this told us that the arsenic that was present in the king's hair must have been ingested by the king. In other words, it was likely to have been given to him as part of a medication. Although arsenic has been used as a medication, it actually wasn't on the list of any of the compounds that was given to the king. The king was largely given antimony-based drugs. Antimony was used as a purgative or as an emetic to try and clear the king's symptoms and relieve his stomach ache. But the way that antimony was prepared in the late 18th and early 19th century was by a crude method, which meant that it was co-purified with at least 10% arsenic. And based on the amount of antimony that was given to the king, we estimate that he was also receiving at least 2.5 milligrams of arsenic a day. And that would explain why we were seeing arsenic in the king's hair sample and why the king's condition was so much worse. That arsenic was also interfering with his heme pathway, making his porphyric attack much more severe, much more longer lasting, and why it nearly killed the king. We know that because arsenic is a known inhibitor of that heme biosynthetic pathway. So in summary, what we've been able to do is to look at the madness of King George. We've looked at it from a biochemical perspective. We can understand that the king appears to have inherited a faulty gene which causes a metabolic condition called variegate porphyria. When he suffered with that condition, he was given medication which made his condition an awful lot worse and made it much longer lasting. This work was done as part of a broader collaboration with many very helpful scientists. In particular, I'll just highlight Professor John Roll from the University of Sussex and my colleagues at the time, David Hunt in London, George Elder in Cardiff, and Tim Cox in Cambridge. And we're very grateful in particular to the Wellcome Trust who provided funding. Thank you very much for your time and attention.